This? Did I get it to you or no? Oh, my bad. Equation in the back. There you go. I think I gave you it all. Guys, it feels thick, but again, I gave you the answer key. So.
You did?
What?
You did?
Yeah, I always do.
Where?
Bless you.
Where?
All right, so.
Where?
First it says, state if the triangles in each pair are similar. If so, state how you know they are similar. Complete similarity statement. So before we get into this, let's review what makes a triangle similar, right?
Just go back to the confused right now.
Why?
Can you give us the answer?
I'll never tell. All right, I'm being tricky. But these triangles are similar. They're not the same, right? Because they're different sizes. So they couldn't be congruent. But they are similar. Because there is a number that you can multiply this triangle by to get this triangle, right? Might be hard to see at first. But what number would I multiply all these sides by to get these sides? Three times 5 gives me 15. 4 times 5 doesn't give me that. I tricked you.
Oh, 3.
It's 3. I just goofed them, didn't I? 3 and 3 goes here. 5 and 3 goes here, and 4 and 3 goes there.
Oh,
You see it now, right? So that's as hard as those can get. You have to be careful, right? Don't just look at the first one and assume you know it, right? These triangles won't always be laid out so nicely. So it's times 3. 3 times 3 is 9. 4 times 3 is 12. 5 times 3 is 15, okay? So we say they are similar because there's a number that takes one to the other, right? Multiplication-wise. And if you're not sure what that number is, you can write the sides like this. Whoops. 15 over 5. And if these all end up being the same fraction, then yes, they are similar, right? What's 5 divided by 15 divided by 5? What's 12 divided by 4? And what's 9 divided by 3? So they will be similar, right? Now, you got to be careful which ones you pair up. A lot of you guys are thinking 15 and 3 went together times 5, right? But if you can find a way to pair them up, that's the way to do it. This is the trickiest that they can get. So if all 3 sides are proportional, meaning that we can write them together like this and they all equal each other, right? Then they're similar. So by side similarity, those are similar triangles. This triangle is similar to that triangle. So Alex, congruency symbol means they're exactly the same, right? Similar is just the top part of that, just the squiggle, the tilde, right? Means that they're similar. And similar triangles have proportional sides, meaning that sides match up, 3 and 9, 4 and 12, 5 and 15, right? They all match up by something. And their angles will be congruent. So if they're similar, which we just proved they are, right, then I know that these angles must go together. 3 and 5 go together. 15, that's 3 and 4, yep. So these angles all must go together. Does that make sense? If the triangles are similar, the angles are congruent, okay? And if the triangles are similar, the sides are proportional. So, we have 3 ways that we can say triangles are similar. If all 3 sides are proportional, then they're similar, right? If 2 of the sides are proportional and they have an angle in between that they share, then they're similar. Or the one thing that we don't use, really, for congruency is angle. So if 2 angles are the same, then we get the third angle for free, right? So we don't even need 3 angles. 2 angles is enough to get the job done, because the third one we get for free. If 2 angles match, then the triangles will be similar, okay? So those are our 3 things we're going to be looking at for similarity, okay? Angle, side angle, side, and side. Now remember, unlike congruency, the sides won't be congruent, right? We're not talking same numbers. Oh, that side's 3, this side's 3. We're not talking that, okay? We're talking about, is there a relationship? So look at number 2 first. Let's look at this one. Now, all they gave us was sides. right? So if they are similar, we're going to use this one, right? That's the only one we can use. We don't have any angle information, so we wouldn't use those. So the question is, are the sides proportional? Well, if you take the smallest side on this triangle, that's 8, right? And you put it with the smallest side on the other triangle. What's the smallest side on this triangle? 48. And then you take the medium side. What's medium on this? What's the medium on triangle HGF? Nope, that's the smallest. What's the medium one?
Oh, 14.
That's the biggest one. 12. 12 is medium, yep. It's all good. Now what's the medium on this one, ABC? It's not 48, we already used that. 72 is the next biggest, right? I always choose to go from small to big. So small triangle first. What's the biggest side on the small triangle? 14. And what's the biggest side on the big triangle? 84. Now, if this is true, what I just wrote, then they're similar by side, side, side. Okay? Remember, relationships between numbers are revealed when you divide them. Right? 6 and 3, how are they related? Well, what's 6 divided by 3? 2, right? That's how they're related. So when we write division, it shows how they're related. So we can reduce these fractions. What are both of these divisible by? 8 and 48, what are they divisible by? 8. 8 divided by 8 is 1. If you don't know 48 divided by 8, I bet you know 40 divided by 8. What's 40 divided by 8? Think a clock, right? 5. So 6 for 48, right? So if all of these are 1/6, then we win. So let's check them. 12 and 72, let's reduce that. 12 and 72. They're both divisible by what? By 6? Or 2? They are divisible by 12, aren't they? Right? But if you don't know that, you can divide by 2, right? And we get 6 over, what's 72 divided by 2? Well, better question, what's 70 divided by 2? 35. So 36 must be this guy, right? Now I bet you know that's not done being reduced, right? What are they both divisible by? 6, so 1 over 6, right? Looking promising, right? All three have to be the same, though. 14 over 84. Maybe you don't know what divides them, but I bet you know one number does. What? 4 won't work. 4 doesn't divide 14. 7 does work. What about 2? Let's keep it simple, right? So if I divide the top by 2, what do I get? 7. All right, bottom by 2. Let's do this in our heads. What's 80 divided by 2? It's half of 80. 40, right? What's half of 4? So it's 42. Yeehaw. Should we listen to some? No, I already did that. That's not done being reduced. Now, only one number goes into 7 itself, right? So if I can put 7 into 42, then I can reduce it. If I can't, then I'm done, right? So all we got to do is check 7. Can 7 go into 42? It does. How many times? 6. Very good. So that becomes a 1, and that becomes a 6. They are similar, right? In other words, we say the sides are proportional. When we have relationships, right, 1 and 6 is related, right, 8 and 48 are related. If our relationships are all equal, then the triangles are similar. We call that being proportional, right? So we'd say by side, side, side similarity, these two triangles are similar. So triangle CBA is the one on the left, right? CBA. Now it's matched up with the one on the right. Notice that C, it's made up of the smallest side and the biggest side, right? Smallest side and biggest side over here is this side and this one, so that's going to go with F. You guys see how I matched those up? Smallest side over here, biggest side over here, that's what C is, right? So I go over here and find the smallest side and biggest side, that's F. B is made up of smallest side and the medium side. So I go to small side and medium side over here. What's that going to go with? What's B going to go with on the other triangle? G. Because smallest side here and biggest side here is B, right? Smallest side, smallest side, and smallest side and medium side is here, right? Small side and medium side over here is G. Bless you. A, well, in this triangle, that's the biggest side and the medium side, right? So if I go over here, biggest and medium is H. If you want, you can write little S's, little M's, and little H's, or B, I guess, for big, to mark which side's which, right? This guy's the smallest, that guy's medium, that guy's large, this is small, this is medium, this is large, and help you match stuff up. C is small and large, so I go over here, small and large is F, right? How do we feel about that? Maybe not 100%, but doable? Okay. Let's check out number one. So we got two triangles here. Well, first off, they only gave us two sides. So we can't use side, 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 right? So it's got to be one of these if it's possible, right? Now, both of those require angles. Now, we can't just say, oh, those look the same, they're the same, right? What angles in this diagram do we know have to be congruent and why? Alex? What angles in this diagram are congruent? So SUT and DUE, these two angles? Yep, and why are these two angles have to be congruent? Does anybody know? Eads. Why do these two angles have to be congruent? Scissor theorem, exactly. Vertical angles, right? So those have to be the same. I don't know anything about the rest, right? But those have to be because we have an X. You guys see that? You with me on that? Okay. So I want you to write vertical angles theorem. That's how we got those. And now, look what we've got. We've got side, angle, side in that order, right? If you look at one triangle at a time, side with an angle in between and a side. So potentially they could be similar, right? By side, angle, side. We got to check their sides, right? And maybe you don't see how these go together. So let's write them out. It's going to seem silly in a second, but we'll write them out. What's the biggest side that we know about in this triangle? On this one right here. What's the biggest side? 40. And then what's the biggest side we know about here? Well, it doesn't matter. It could be either or, right? Let's go with 16. Equal. Other side we know about is 39, right? And that's a 16, so it's got to go with that. If it's similar, they'll go together, right? Now the question is this true? Well, we can reduce one of these, right? What's 40 over 16? How do I reduce that? What are both divisible by? 4. 2 works, but 4 works even better. What's 40 divided by 4? And 16 divided by 4 is? 4. Okay, good. We can keep going. Can I divide those by 2 again? So 5 over 2. Now this one, I'll spare you the trouble. They're not going to be the same. If I've got 40 sixteenths and 39 sixteenths, is that the same thing? No, it's 1 less 16th over here. They'll never end up being the same. They're not equal. They can't be. We didn't need to reduce that. It's obvious they can't be. Can't be the same. So they're not similar. An easy way to figure this out is to look at the triangles. Notice both these sides are the same, right? So if this triangle was to be similar to this one, wouldn't these both have to be the same? Right? They might be a different number, right? But they both have to be the same. So not similar, not going to work. That's another way to look at it. So since these two sides are the same, that's an isosceles triangle, right? Is this isosceles? Not as far as we can tell, right? Isosceles triangles are only similar to other isosceles triangles, right? If some magic happened where these are both 40 somehow, and those are both 16, maybe, but even then, angle in between, side angle side is what we were looking for. It's not going to happen. Let's look at number 3. All right, somebody other than Eads. What do we know about this? Yeah. No, because we don't know that these are right triangles. It looks like it's a right triangle maybe here, but we don't know that for sure. If it was a right triangle, then we can get the other side, and then we can compare them all. That's really clever. But we don't know that it's a right triangle. Two sides isn't enough to get the job done, right? We can't even check to see if it's similar. If that's all they give us, right, then no way. Not enough to tell. But there's something else here that we can put in our diagram that's going to help us out. I was going to say someone other needs. You guys see the X again? Vertical angles. Vertical angles theorem, VAT. So now if they are similar, they'll be similar by side, angle, side, right? Now the question is, are the sides proportional? So let's compare them. Maddie, either or. What's the smallest side on this triangle that we know about? 8. So it should go with the smallest side on this triangle. What's the smallest side in this? Oops, smallest.
Oh,
28. Yep. That's all right. I don't care about whether you're able to think of which number is smallest in your head off the top, you know. I know you all can. What I'm interested in is, do you see the sides? Alright, so 8 goes with 28, and then 14 should have to go with 49, right? Smallest side should be related, bigger side should be related, right? That's the idea. And relationship we show by division. Now the question is, are they related the same way? Does 8 relate to 28 the same way 14 relates to 49?
No.
Well, we're going to find out. Let's reduce this one. What are both divisible by? 8? 8 doesn't go in 28. 4. 2. How many times does 4 go into 20? 5 times. Add one more 4, we're up to 24, right? Add another 4, we're up to 28. So 4 must go into 28 7 times. We get 2 over 7. Does 2 go into 7? No, so we're done. Right. Now what about 14 over 49?
7.
Both are divisible by 7, yeah. What's 14 divided by 7? Ooh, looking promising. What's 49 divided by 7?
7.
Are they equal? Yeah. So we got proportional sides, right? They relate the same way. So this must be similar. Now, why are they similar? By what? Side angle side similarity, right? SAS similarity. They've got an angle in between, and they've got 2 sets of proportional sides, right? So that's side angle side. You guys feeling that? Side angle side is how we know they're similar, right? They have matching angles and then 2 proportional sides, right? In that order: side, angle, then side. So now let's match them up. We got VUT, so that's this triangle, right? V on this triangle, that's made up of the red and the blue, right? My biggest and my smallest. What angle is made up of my biggest and smallest sides over here? Angle M, L, or V? We got my biggest and smallest sides make up V here, right? So in this triangle, biggest and smallest, also angle V, right? And that makes sense because they're vertical. They go together, right? What's going to go with U? Well, U is unknown and smallest, right? Unknown and blue. If I go to my unknown side and my blue side, they make angle L, don't they? What's up with L? All right, last one. Red and unknown. What's red and unknown? M. Red and unknown makes angle M. That last bit, when we do a quiz, you'll need to match up the letters correctly. That's very important. It's not hard to do once you see it, so make sure you're seeing it. If you're not seeing it now, ask me about it, okay? And I'll show you how it works. How'd you feel about 3? Feel okay? Starting to get the hang of it? Let's look at 4. Did they give us any information about sides? No, and we're not getting them. It's not going to happen. So if they're similar, they have to be similar by something that doesn't require sides. We got 3 things. Side, side, side. That's not going to get it done, right? We don't know anything about the sides. Side, angle, side. No way. Double A could get it done, though. Remember, similar triangles have congruent angles. Do we have 2 sets of congruent angles here? Yeah, you love this one. So it's similar. We say by angle, angle, similarity. Triangle JKL, similar to the other triangle. Now let's match them up. Angle J goes with what angle in the other triangle? What do you think? T, right? And K is double barred, so it's going to go with U. And L's the leftover one, so it must go with V. Cool. You guys like angle, angle, don't you? All right, let's take a look at 5. Take a gander at 5. First of all, what do you see? As soon as you see this diagram, something should jump out to you. A couple things. Vertical angles, right? We got an X. So these angles are congruent. Do we have 2 sets of congruent angles?
Yeah. No.
We got 1 set here. Other one's single bar, double bar, and triple bar. Now, could they end up being congruent some way, somehow? We learned later that double bar and single bar are the same. Yeah, but right now we don't know. So do we have enough information to say they're congruent? No, not enough information. Unknown.
What does that say?
Unknown.
Oh. I get that. I was like,
It's a lot of, yeah, it's a lot of whoop. UNKNOWN. Yep. A lot of squiggles. Unknown. We don't know about it. Is that what you got?
Yeah.
Is that what the answer key said?
I don't know.
you said not similar.
Yep.
Not similar.
My take on that, and I was hoping Mr. Eads would ask, but he didn't. He didn't look at the back. So, my argument would be that there's not enough information to prove them similar or not. Now, if we knew for a fact that single bar, right, doesn't equal this, and single bar doesn't equal that, then I'd say sure. So here's how I think about it. You ready for some Greek letters? You guys like my writing. Let's call this alpha. That's a little squiggle A, like this, alpha. We use Greek letters when we talk about angles. Okay. Let's call this angle beta. Here's beta. It's like a B with a tail. Let's call this one gamma. It's like a Y kind of. It dips down and comes back up. Now, if we knew that these 3 don't equal each other, then we could say, oh yeah, definitely not similar, right? They won't be similar. 2 angles have to be the same. 2 angles aren't, right? We have all different angles. So not similar. But what if alpha does equal beta? You guys know that happens in algebra sometimes, right? Sometimes x equals y, sometimes they're the same number, right? So my argument would be that right now, as listed right here, they're labeled as 2 separate angles. So they could be 2 separate angles. But there is one case where we learn later that they end up being the same. I don't know. It's how I label my diagrams. So I'd say not enough information. Other people might say definitely not similar. It's how you interpret what these signs mean. I'm just going to say not enough info. Number 6. Whew, this is kind of weird looking one, right? How many triangles do you see here? 1 big one, right?
Oh, 2.
And then a small one, right? Is this a triangle?
No.
It's not, right? Yeah. So we do just have 2 triangles. Okay. We've got 2 triangles, right? Now we got to match up their sides. Now, which triangle's smaller? Give me the 3 letters. Which are the smaller ones?
KBC.
KBC is a small triangle, right? So let's start with that one. What's the smallest side on KBC that we know about? 16. All right, starting from the small triangle. And what's the smallest side on the bigger triangle, right? This doesn't count as a triangle. Well, we have to do some math, or maybe we can just think about it a little bit. KL is 88, right? Is this side going to be smaller or bigger than 88?
Bigger.
How do you know it's going to be bigger? Well, you can add them up and see it's bigger. But isn't this one already bigger than 88? So if I add up 25, it's still going to be bigger, right? I don't care what that equals. Not yet, at least. So I know the smaller side's going to be 88 for the other triangle. It's weird when they overlap. But do you guys see how the two small sides go together? Small side of this guy is 16. Small side of this guy is 88. Cool. Now we're going to check and see if that's proportional to the other sides. What's the bigger side on KBC? Only thing funnier than 24, 25. Now this side is the bigger side for the big triangle, right? The big guy, right? And that's going to be, what's 107 plus 25? Better question. What's 25 plus 7? Better question. What's 25 plus 5 plus 2?
That's 132.
I'll write it out. I know it's going to be 100 something, right? So I just need to focus on 25 and 7. Well, if you want, can't you think of that like this?
32.
Yeah. So that's 32. So it's going to be 132. Does that make sense? Right, 25 and 7, I'll screw up in my head, but 25, 5, and 2, I can do that. 25 and 5 is 30. 2 more is 32. So now the question is, are these proportional? Are they equal, right? So we got to mess with them. Let's go with the one I know. 16 over 88. What does that reduce to? What can we do to reduce that? We divide by 8 for both. Yeah, that's true. So what does that become? 16 divided by 8 is? And 88 divided by 8 is? 11, right? I love 11s. Now, you might be thinking, oh man, how do I reduce that? I don't know, right? Well, first of all, there's only a couple numbers that go into 25, right? 1, not very useful. 5 and 25, right? Does 5 go into 132? No, it goes into 130, right? So it can't go into 132. Does 25 go into 132? Think about it. 25, 50, 75, 100, 125, 150? No, it doesn't. So that won't reduce this ever. It won't reduce at all. Another way to think about it is I got the 16 down to a 2 and had to stop, right? If these are the same, I should be able to get that down to a 2 somehow, right? So it's 2 over 11. Can I ever get 25 down to a 2? No, it's odd. I can't. So there's no way I'm going to make that 25 a 2 and have it match and then make that an 11. Now you might look at 132 and go, how am I going to make that 11? I don't know. Maybe there's some way to do it. But 25, get it to a 2? That's not going to happen, right? So they're not similar. And we know for sure this is not similar. Now, I forgot to point out, all we had were 2 sides, right? So even if we did get them similar, we wouldn't have had enough information because we just have 2, right? Don't we need 3 sides or at least an angle? Now, I'll tell you right now, we wouldn't have gotten this third side. There's no way to get it. It's not a right triangle. We can't do p-vec. Do you guys see an angle that's the same both for this triangle and this triangle? Angle K. They share it, right? You gotta go. Is that what you said? Or you point out K?
No, I was pointing out.
Oh, yeah. They share that angle. So we can write shared angle. So if these were proportional, then we'd have side and side, right? Good job pointing out that shared angle, guys. That was really good. We're going to do more of this tomorrow. But you've got the answer key. If you want to jump ahead, go ahead. 11 and 12 are a little tricky, as you might see. Oh, yeah, go. Right here. Not even close. You got to get like a flag, like they do for golf. So you know where the hole is, right?
You should. He needs a funnel.
I have a funnel. I used to teach AP Calculus, college preparatory class.
Is that ours?
Got to get them ready for college. I see a furrowed brow.
You have a, yeah.
All right.
Well, $100. You have a lot of them. Yes. You have 2 jobs. You have a lot of them. These, I quit my 13s. I'm done with some of these. 44.
Well, they have to be. They have a shared angle. And not unless this is a parallel. Maybe this is a parallel. Right, so it could be not. So maybe it's not.
Can't do what?
And the answer, he said what?
It says it's similar.
Interesting. Let me check.
It says it's similar by side, side, side. If you're not using that, then you have to
Not
side
a
angle
ton.
side.
We did more stuff with perpendicular by
And if
side.
they're similar, then these angles have to be the same, which would make those corresponding angles, which would make those 2 parallel.
Right, yeah. Yeah, it's all kit and caboodle.
Yeah.
But, so 44, 121, 411. Yeah, because 111 goes to both, yep. And then 88 and 143. Well, we can make 88 go into 4 by dividing by, we have to divide by 22, right? So we have to divide this by 22. You're not going to be able to divide that by 22. So there's no way. Now maybe we have our sides mixed up. No way. Biggest side, go with the biggest side, which would end up being this.
And then the bottom piece, bottom piece.
Hold on. We need to figure out what these sides are here and here. 88 minus 56 is that side. 143 minus 91 is
But
that
it
side.
doesn't matter whether you do piece to piece. Because if they're similar, these are parallel, so it doesn't matter which piece you use. Because either way, these,
Okay, yeah.
the whole sides are going to be 8/13. So this to this is going to be 8/13. This to this is 8/13. So these have to be 8/13.
32 out of 88 over this way 8. So 4 over 11. Yeah, that reduces to 4 over 11
This
now.
is 32.
Yep, and that'll be 4 over 11.
And then 143 minus
52.
91 is 52.
52 out of 143 are both divisible. Well, both should be divisible by 11.
So this is 8/13 as well. So 32 over 52. This is 8/13. This is 8/13. And these are 8/13, but this side is not. The other side is not.
Is 52 out of 143 8/13? Or is it 4 over 11? So I think the issue is in how we're comparing them. I think that this triangle we're comparing to the big triangle. And so we have to compare this side to the whole thing. And this side to the whole thing. And these we can't compare.
You have to compare triangle to triangle.
Right, but that's not part of the triangle. It's part of the block. So we have these sides. Like if I were to extrapolate this, right? If I were to pull that out, we'd have this triangle and then we have this large triangle. We wouldn't even know about these 2 here.
But it should work either way you do it.
Should it?
Yeah, especially if these are parallel. But then, if we did this to this part, the 88.
Or maybe 8/13 is, yeah, they're similar, but they're by a different proportion. So this and this would compare to these in the same way, right? But it'll be by a different proportion. It's a different relationship.
So this side to this.
Yeah, these.
This side to this.
Yeah. So this triangle.
These to these would be all before.
Yeah. So this triangle and this triangle would be similar by this proportion, right? And then this shape, you see what I'm saying? That would be similar to this big triangle by a separate proportion.
Okay, I'm not triangle. I'm doing proportional
Right, exactly. You're
sides.
doing proportional sides in general. Yeah.
Yeah.
And they will be similar, but they'll be similar by a separate proportion. I had that same issue the other day when I was proving
Because I'm
PFAG.
still doing the other proportions.
Right, yep. Because I was doing
I'm
this with
doing so
Dave.
much of it that it's like, ugh. It's all mixed up in my head.
When we proved PFAG the other day, I was doing this with Zayden after school, and I was like, okay, small and medium are related by proportion, small and large are related, medium and large, and I took this and I said, oh, that's all true. then this must be true. Right? But it's not. Because the way small and large relate to small is smaller than large, or smaller than medium. There will be a bigger jump to get there than from medium to large. So they're all similar, but they're all related by different proportions. It's, yeah. I hadn't thought about it like that either. And, yep, screws with your mind. Yeah, grab that stuff, let's get out of here.